Welcome back, students. Until now we seen physical properties of acids, after that chemical properties of acids. Now we will going to study about uses of acids. Which uses? Industrial uses of acids. In that first one we have hydrochloric acid, HCl. It is used for cleaning metallic items in dyed stuffs in printing industry. It means in the printing industry the hydrochloric acids are going to be used for the cleaning them or metallic items. For the metallic items also hydrochloric acid is going to be used for the cleaning. Okay. Second, sulfuric acid. Sulfuric acid is used in the manufacturing of fertilizers, chemicals, paints, dyes, plastics, synthetic fibers, explosives and car batteries, etc. It is called king of chemicals. H2SO4 is known as king of chemicals and which is used for the manufacturing of fertilizers, chemicals, again paints, dyes, colors. For the colors also it is used for making synthesis of plastics. After that synthetic fibers, it is used for also synthetic fibers, explosives and car batteries also. Okay, so third acid we will see nitric acid. It is HNO3. It is used in manufacturing of fertilizers, dyes means colors and plastic and drugs. This HNO3 nitric acid is going to be used for the drugs also. Okay, for manufacturing of drugs. Next one is acetic acid. Acetic acid is used for the preservation of food. Okay, when we are doing pickles, at that time we are for the preservation of pickles we are using acetic acid. So it is used as a vinegar in cooking. As a vinegar it is used in the cooking. Okay, and food preservation. This acetic acid is used for the preservation of the food also. So what is the formula of acetic acid? CH3COH. This is all about acid. Okay, so we see what is acid. After that, physical properties of acid, chemical properties of acid, and some uses of acid. Now today we are learning about bases. Okay, so what are bases? Bases are substance which have bitter taste, means kadwa taste. Okay, and soapy to touch. It means slippery touch. It gives slippery touch. Turns red litmus to blue. It turns red litmus paper into the blue litmus paper. Okay, so what are the examples of bases? Calcium hydroxide, ammonium hydroxide, potassium hydroxide, sodium carbonate. These are the examples of bases. Magnesium hydroxide. These are the examples of bases. Okay, so bases are substance which have bitter in taste and soapy to touch, turn red litmus to blue litmus paper. It's called as bases. Okay, in the previous part we seen Arrhenius concept of bases. What is in aqueous solution? It gives hydroxide ion known as bases. In acid it gives H plus ions that called acids. Okay, according to the Arrhenius. Now we will see physical properties of bases. We see physical properties of acids also. Now we will see physical properties of bases. In that first we will see taste. Taste of bases, we know that bases have bitter taste. It means kadwa. Second one, feeling of touch. We know that already mentioned in the definition, which have bitter taste and soapy to touch. It means like our soap, while we are touching to our soap, at that time it gives slippery touch. Okay, so that kind of touch it gives. After that, feeling of touch, base gives a feeling of soapy to touch. Effect of indicators. effect of indicators. Why need indicators? Because we are unable to test every base, okay, or every acid. That's why we are using indicators. So what is the role of indicator? To identify the nature of acid or basis or substance, okay, to identify the nature of substance. So effect of indicator, first we will see basic solution turn color of red litmus to blue. So we will see one by one, okay. Practically we will see, we are having base sodium hydroxide. We are having base sodium hydroxide. This is red litmus paper. According to definition, red litmus to blue. What it will change? What it will change? This red litmus paper will change into the blue litmus paper. We will see it, okay. So this is red litmus paper. Why we are putting based on it, the color of red litmus paper gets changes into the blue. It means that this is base, okay. First test of, that is litmus paper. What about methyl orange? Whenever in the basic medium methyl orange form changes its color orange to yellow. In the basic medium it changes orange to yellow. We have to see that whether this is giving change in color. So methyl orange, see the color of methyl orange. Methyl orange is having color, that is orange. It will change into the yellow. So see it. It gives yellow color. It is the action of methyl acid on base. Okay, when base we have, at that time methyl orange changes into the yellow color. When we are using phenolphthalein indicator, at that time in basic medium the colorless medium changes to the pink. Colorless medium changes into the pink. Okay. Already it touches with the phenolphthalein indicator, that's why it's giving pink color directly. See this is colorless solution of base. When we can say that if we are using phenolphthalein indicator, at that time it changes colorless color to the pink color, then we can say that it is base. So we are having phenolphthalein indicator and it will change its color into the pink. Okay. So these are the effect of indicator on the base. The fourth property, that is fourth physical property, electrical conductivity. Yes, of course, this basic solution conducts electricity. Because of it produces hydroxide ions, okay, cation and anion. That's why it is going to be carry electricity. Okay, so what we learn today? Today we learn about the industrial uses of acids. In that we see first hydrochloric acid used for the cleaning of metallic atoms in the industry and in dye stuff in printing industry. Okay. After that we see sulfuric acid H2SO4 used for the manufacturing of chemicals, paints, dyes, plastics, synthetic fibers, explosives and car batteries etc. And it is known as king of chemical. It is known as king of chemical. Nitric acid, uses of nitric acid in industry, we see that it is used for the fertilizers, manufacturing of fertilizers, dyes, plastics and drugs. After that we see acetic acid CH3COH, it is used for the food preservation. Okay, and vinegar in the as a vinegar in cooking. After that we started our new point, that is bases. Okay, so bases are substance which have bitter taste and Sophie to touch and turn red litmus to blue. We seen also with the practically also. We have the example calcium hydroxide, ammonium hydroxide, potassium hydroxide, magnesium hydroxide. These are the example. Physical properties of bases. In that first we seen taste of bases, bitter in taste, feeling of touch, Sophie to touch, effect of indicators, basic in the red litmus paper changes into the basic medium blue. Methyl orange, if the color is orange of methyl orange, then it will give color to the yellow color in basic medium. If we are using phenolphthalein indicator, the color changes colorless to color. Pink color. And electrical conductivity, if we are talking about electrical conductivity, then basic solution conducts electricity. I hope that you understood today's part of this industrial uses of acid and bases. Okay. Once again we will revise with the help of AV this all part of acids. Okay, so watch it carefully, my dear students. Stay safe, stay home. Thank you. Have a nice day.
Hello everyone. This PowerPoint slide presentation is on the topic acids and bases. Previously, we have learned the properties of acids and alkalines in our secondary 1 syllabus. It is pretty much similar, just that we will be learning the concepts in greater detail this time round. Can you think of some examples of acids in our everyday life? Well, I have here citrus fruits which contains citric acid, vinegar which contains ethanoic acid, Coke contains carbonic acid, car batteries contain sulfuric acid, and certain green vegetables contain folic acid. A history on how acids came about. The ancient Greeks used taste to distinguish acids. In Latin, sour-tasting things were described as acri, which is known as acidic and evolved into the term acid. Acidic substances were eventually found not only to taste sour, but also to change the color of litmus paper and corrode metals. In contrast, bases were typically defined and studied by their ability to counteract acids. Now, let's look through the properties of acids. Acids are soluble in water. Acids are good conductor of electricity in aqueous solution. Acids that are very concentrated are very corrosive and can cause acid burns. The pH of acids are less than 7 and turns blue litmus paper red. So, what exactly are acids? Acids form hydrogen ions when dissolved in water. As seen in the diagram, the hydrogen chloride molecules dissociate to form hydrogen ions and chloride ions. The hydrogen ions are the ones that give acid its acidic properties. So, when acids are not in aqueous solution, it actually do not display acidic properties. Next, there are two types of acid, namely strong acids and weak acids. For strong acids, all of the acid molecules will dissociate to form hydrogen ions. So, from the diagram, you can tell that there are no more acid molecules. It has dissociated completely into hydrogen ions and chloride ions. Some examples of strong acids are hydrochloric acid, sulfuric acid, and nitric acid. Please memorize the chemical formula of these three acids as you will need them when writing chemical equation. These are also the acids that we use very often in the lab. Whereas for weak acids, only a small fraction of acid molecules will dissociate. From the diagram, you can tell that most of the acid molecules remain as acid molecules. And if you look carefully, the number of hydrogen ions is much lesser than the strong acids as shown previously. Some examples of weak acids are ethanoic acid, citric acid, and ascorbic acid. Weak acids can be found frequently in our food. We are now going to learn about the chemical properties of acids. From your Secondary 1 syllabus, we have learned the 3 general reactions of acids. Acid reacting with metals, acid reacting with carbonates, and acid reacting with alkalines. So now, let's go through the first reaction. If you can recall, acids react with metals to form salt and hydrogen. For example, magnesium metal and sulfuric acid reacts to form the salt, magnesium sulfate, and hydrogen gas. How do we identify that the salt was magnesium sulfate? We actually derived it using the names of the reactants. Since we use sulfuric acid, it gives us sulfate salt. And with magnesium metal, that gives us magnesium sulfate. And to add on, hydrogen gas can be identified using a burning spleen. If hydrogen gas is present, burning spleen will extinguish with a pop sound. Next, the second reaction is the chemical reaction of acid with metal carbonates that will form salt, water, and carbon dioxide gas. We shall look at one example. When sodium carbonate reacts with hydrochloric acid, the salt form is sodium chloride. Carbon dioxide and water are also products of this reaction. Similarly, we derive the name of the salt from the name of the reactants. Please note that carbon dioxide can be identified by bubbling the gas through lime water. What precipitate will be formed in lime water? Some students tend to describe this observation as lime water turning cloudy. Sad to say, teachers will not accept this as a valid answer. For the last reaction, we need to know that acid react with bases to form salt and water. Previously, we have learned it as acid reacting with alkaline, but now we will need to use a different term, base. So, what is the difference between the term base and alkaline? Basically, alkalines are bases. Not to worry, we will learn more about bases in the next PowerPoint presentation. For now, just remember that acid and bases form salt and water. Let's take a look at one example. Can you tell me what salt will be formed when we react nitric acid and copper 2 oxide? If you had understood what I have taught previously, you will know the answer is copper 2 chloride salt and water. And this reaction is a neutralization reaction. So with this, I have come to an end of this PowerPoint presentation. In the next week, we will be learning more about bases and alkalines and their chemical reaction. Thank you for listening.